So dye dilution method. So a common method of for measuring cardiac output is dye dilution method. So similar to your indicator dilution method, it is going to be acted. That is nothing but instead of indicator, you are going to use dye here. Okay. So colored dye indocyanamine green. So this is used for diluting in the blood, that is hot blood. Okay, blood which is flowing in the heart. So here this indicator, that is dye, going to meet and necessary requirements. So here the dye will be available in liquid format, which will be easily diluted in the saline, isotonic saline, and injected directly through a catheter. So through the catheter only you are going to inject into the heart of the human body. Okay, so in which heart part you are going to inject means it is nothing but pulmonary artery. Okay, through pulmonary artery you are going to inject the dye, colored dye, cardio green. Okay, so here 50 percentage of the dye will be excreted by the kidneys for first 10 minutes. Okay, so if you apply the dye in the hot blood, then it will be excreted in the kidney. Okay, I think you all know what is excretion. Okay, uh, filtered. Okay, excreted by the kidney for first 10 minutes only. So this will be repeated whenever you are adding the dye to the blood measurement in the hot. Okay, so the plot of the curve for concentration versus time will be obtained by constant flow pump, which will draw the blood from a catheter which is placed in the brachial artery or femoral artery. Okay, so we can get the output uh, based on the concentration of dye present in the blood flow of hot clot. Hot blood will give the plot curve. Okay, we can receive the concentration of dye by placing the catheter at the femoral or brachial artery of heart. Okay, you are going to inject the dye in pulmonary artery, but you are going to take the output only at femoral or brachial artery. Okay, so based on the concentration level of dye, it will give the cardiac output. So cardiac output is nothing but blood flow in the heart for per minute is said to be cardiac output. Okay, so blood going to be drawn through a calorimeter cuvette which continuously measures the concentration of dye using the principle of absorption photometry. I காலையில தான் சொன்னேன், EC students may know what is calorimeter cuvette. So calorimeter cuvette is used to collect the blood. Okay, so in that you are going to pass the light. Okay, that is photometry, absorption photometry. So when you are passing the light through the blood, it will absorb the particles which is present in the blood will absorb some light energy. Okay, so that you will be getting less intensity when your light leaves the calorimeter cuvette. Okay, this is the concept of absorption photometry. The next type, thermodilution. So nowadays thermodilution method is popular for measuring the cardiac output. Here bolus of 10 ml of 5 percentage dextrose will be taken in water at room temperature. It's going to be injected in a as a thermal indicator to the right atrium. Right atrium le we are going to inject the bolus. Okay, 10 ml of bolus with 5 percentage of dextrose. Okay, bolus mixed with dextrose, and then it will be used as a indicator, with thermal indicator that going to be mixed with blood of heart in the right atrium. Okay, so after mixing that bolus, okay, that is the thermal indicator, the blood going to be detected, that is we are going to detect the cardiac output at pulmonary artery. Okay, we are going to inject at right atrium. Here we are going to detect at pulmonary artery using thermistor. Okay, which going to be mounted at the tip of catheter probe. So using catheter only you are going to inject as well as take the output of cardiac output. So the temperature difference between the injected temperature and the circulating blood temperature in the pulmonary artery is going to be measured. Okay, so inject பண்றப்ப எவ்வளோ டெம்பரேச்சர் இருந்தது, அதுக்கப்புறம் இன்ஜெக்ட் பண்ணி அந்த சர்க்குலேட் ஆன blood நம்ம பல்மனரி ஆர்டரியில் எடுக்கிறப்ப எவ்வளோ டெம்பரேச்சர் இருக்கு. ஸோ தீஸ் டூ டெம்பரேச்சர் மெஷர்மெண்ட் டிஃப்ரென்ஸ் வேல்யூ வில் கிவ் த cardiac output. Okay, so the temperature difference taken with respect to time. So எவ்வளோ நேரம் கழிச்சு எடுக்கிற, ஓகேவா, at what time you are injecting the thermal indicator into the blood, at what time you are going to take the blood out for measuring the cardiac output. So based on that timing period, okay, time period, you are going to measure the temperature difference with respect to the time period. Okay, for getting the cardiac output. The next method, impedance change method. So first method by applying injecting dye, that is dye dilution method. The next method, temperature. Okay, based on temperature you will be getting the cardiac output. Here impedance. Okay, I think you all know what is impedance. What is impedance? Any one of you? Impedance. Impedance means nothing but reactance, both reactance and resistance value together will be called as impedance. That means it's going to resist the flow of blood. Okay, so based on that manner we are going to measure the cardiac output. So here we are going to use the electronic method, that is electrode pairs will be used. 1, 2, 3, 4. Four electrode pairs are used. Four electrodes are used. Two pair of electrodes. That is 1 and 4 will act as a one pair, and then 2 and 3 will act as the another pair. Okay, two pair of electrodes but four electrodes. Okay, and then L probe method is going to adapt here. In that 1 and 4 electrode is used as current electrode, 2 and 3 electrode will be used as the picking electrodes. Picking electrode means output electrodes. Okay, 1 and 4 input, 2 and 3 output electrodes, which will be used along the thorax. Okay, so here 100 kilohertz of current going to be applied between the 1 and 4 electrode. So impedance, with impedance value 25 ohm. Okay, so the voltage signal which will be changing the impedance value after amplification and demodulation to get the output value as Z. So this is your four electrodes going to be placed in the heart of the human body. 1, 2, 3, 4. So through the 1 and 4 electrodes, you are going to send the input signal or current. Okay, from the oscillator. Okay, oscillator will send the input signal to the 1 and 4 electrode, and 2 and 3 electrodes are used for collecting the blood from the human body. Collecting the blood from the human body, 2 and 3 electrodes will be used. So electrodes are nothing but which will be converting the biosignal into electrical signal. That a converted electric signal will be given to the A1. A1 is nothing but amplifier and demodulator. I think amplification na உங்களுக்கு தெரியும். What is amplification? Just it will boost the uh, electric signal, a weak electric signal, to provide high amplitude for it. And then given to differentiator. So this circuit, this op amp A2 along with the capacitor resistor, both in input side as well as feedback side, altogether will be called as a differentiator. Stop.